of this function? Well, the domain can contain all real numbers from negative infinity to positive infinity. In the last lesson, we studied the graphs of functions and discussed the information that we can obtain about a function by drawing its graph. In this lesson, we will see how the graph of a basic function can be used to find the graphs of related functions. Alright, what are some of the basic functions? Well, the first basic function you can talk about is f of x equal to x squared. What is the graph of that? How does the graph of that look like? You can see for all inputs, the outputs will be positive. Is that right? F of x equal to x squared. That's the graph of f of x equal to x squared. Tell me, what is the domain of this function? Well, the domain can contain all real numbers from negative infinity to positive infinity. And how about the range? The range can only contain values that are greater than 0. And therefore, the range is 0 to infinity, 0 included. And how about the behavior of the function? We talked about that some time ago. The function decreases from negative infinity to 0. There you are. And it increases from 0 to infinity. Well, these are some of the behaviors that we talked about already. Let's now look at another basic function. F of x equal to square root of x. How does the graph of that look like? That is the graph of f of x equal to square root of x. Well, what's the domain? The domain contains only numbers from 0 to infinity. It does not contain any negative numbers. Domain is 0 to infinity. Range is also from 0 to infinity. And it increases throughout its domain. Increases on 0 to infinity. A third basic function is f of x equal to absolute value of x. How does the graph of absolute value of x look like? Well, you can see for all input values, the output is positive. What is the domain of this? Negative infinity to positive infinity. And the range is 0 to infinity. The function decreases on negative infinity to 0. There you are. And increases on 0 to infinity. Now, don't get confused when you see the arrow pointing. The arrow does not show the value of the function increasing. The arrow simply shows that the output goes all the way that way. In other words, you can see when x is very large, the output will be very large. And as x, now when x is highly negative, that is very low, for -4, -5, -6, that is x decreases, goes towards negative infinity, the function value is very high. And as x increases towards 0, the function decreases to 0. And then as x increases, the function increases and goes to positive infinity. So it increases on 0 to infinity. How about the next f of x equal to x cubed? Well, what is the graph of f of x equal to x cubed? I'm sure you know how the graph of f of x equal to x cubed look like. That's right. What is the domain of this function? The domain contains all real numbers from negative infinity to positive infinity. How about the range? The range is also from negative infinity to positive infinity. There's no break in the graph anywhere. And the function increases throughout its domain. There is no other behavior. It is increasing throughout its domain. A fourth, or is it third? Let's say the next basic function is f of x equal to x. How does the graph of that look like? Look at that graph. All right, what is the domain of that graph? F of x equal to x. When x equal to 1, y equal to 1, x equal to 2, y equal to 2, and so on. The domain is negative infinity to positive infinity. And the range is negative infinity to positive infinity. How about the behavior of the function? It is increasing throughout the domain. Increases on negative infinity to positive infinity. Another basic function is f of x equal to a. What does a stand for? A is a constant. A is equal to 2, 3, can be anything. What it means is that for any input, the output remains a constant. The output doesn't change. So if that a equal to 2, for all x values, the output will be 2. The graph will be a horizontal line. Look at that. F of x equal to a. Its domain is from negative infinity to positive infinity. And what is the range of that function? No matter what the input is, the output is always a. That means the range is simply a. It cannot have any other value. All right. Let's now look at reflection of a graph about the x-axis. Now, what does that mean? Let's study that. Now, how does the graph of y equal to negative x squared differ from the graph of y equal to x squared? Can you think about it? Now, let's draw the graph of these on your calculator. All right, take your calculator and enter these two functions. Press y equal to and type in y1 equal to x squared, enter, and then y2 equal to negative x squared. Now remember, the negative sign here is not the same as the subtraction sign. The negative sign is the sign that is next to the enter on the calculator. So use the negative sign next to the enter on the calculator for that negative sign. Now, what I want you to do is, I want you to draw the graph of y1 first and not draw the graph of y2. So what you do is, go to the calculator, look at the cursor there. Press on the left arrow and bring the cursor to the equal sign and enter. What happens is, it will deselect y2. You will see that black selection will disappear. That means only y1 will be graphed. So y2 is no longer highlighted and it will not be graphed. Now use this window, set this window, x minimum negative 5, x maximum 5, y minimum negative 5, y maximum 5, and draw the graph. You will see the graph of y equal to x squared. Okay, let's now go and graph the y equal to negative x squared on the same screen. That means we will now go and select y2. Now how do you select y2 now? Press y equal to, take the cursor down and keep it at the equal sign and press enter. That's right. And you can now draw the graph and of y equal to negative x squared. Look at that. Y equal to x squared, y equal to negative x squared. And what do you notice here? If you keep a mirror on the x-axis, the reflection of the graph of y equal to x squared on that mirror will be the graph of y equal to negative x squared. Is that right? You are used to seeing the reflection of you in the mirror. Isn't that the same? If you keep a mirror here, the reflection of this on that mirror will be this. That's right. So a mirror placed on the x-axis gives the reflection of the graph of y equal to x squared, and that reflection is the graph of y equal to negative x squared. And therefore, in general, we can say the graph of f of x equal to negative x squared is obtained by reflecting the graph of y equal to x squared on the x-axis. In that case, tell me, how does the graph of y equal to negative absolute value of x differ from the graph of y equal to absolute value of x? Well, you have seen the graph of absolute value of x. Tell me, how does the graph of negative absolute value of x look like? Alright, let's go and draw them on your calculator. Be active when you watch this, and pause the video when you need more time. Alright, type in y equal to absolute value of x by using this keystroke. Press second 0, enter, and you will see ABS with a parenthesis on the calculator. For the second 0, enter, you get ABS, and then type in x. Press that x variable, and that gives you absolute value of x. And y2, start with a negative sign and do the same thing. You get y2 equal to negative absolute value of x. And as we did last time, deselect y2. You can see y2 is not selected now. I have deselected it. And press graph. You find the graph of f of x equal to absolute value of x. And now go back to the calculator and select y2 so that y1 and y2 both will be graphed, and you will see that graph. You see y equal to absolute value of x, y equal to negative absolute value of x. What can you say here? The graph of y equal to negative absolute value of x is the reflection of the graph of y equal to absolute value of x on the x-axis. There you are. F of x equal to absolute value of x. F of x equal to negative absolute value of x. Alright, let's look at another one. Y equal to negative square root x. How does that graph look like in relation to the graph of y equal to square root x? Can you draw those two graphs now? I'm sure you can. So enter these two functions on y1 and y2 and graph them. This is the graph of f of x equal to square root of x, y equal to square root of x. And this is the graph of y equal to negative square root of x. Alright, y equal to square root of x, or f of x equal to square root of x, f of x equal to negative square root of x. Similarly, the graph of y equal to negative x can be obtained by reflecting the graph of y equal to x on the x-axis. Alright, how does the graph of y equal to x look like? That's the graph of y equal to x. Okay, if you reflect this, what will you see? If you reflect this part, you will get something like this here. And if you reflect this on the x-axis, you will get that. In other words, y equal to negative x will go that way. There you are. So this is f of x equal to x. This is f of x equal to negative x. How about y equal to a and y equal to negative a? We saw the graph of y equal to a. Y equal to a is a horizontal line. And if you reflect that on the x-axis, what do you get? This is f of x equal to a, or y equal to a. If you reflect it on the x-axis, you will get y equal to negative a. So here we have now seen many examples of simple basic graphs. When reflected on the x-axis, you get a related graph. Is that right? the graph of negative f of x. So, listen to this again. If you know the graph of f of x, and if you reflect it on the x-axis, you get the graph of negative f of x. Now tell me, how does the graph of y equal to 2x squared differ from the graph of y equal to x squared? Well, y equal to x squared is a parabola, isn't it? Now, how does the graph of y equal to 2x squared? You must keep in your mind the concept of input and output. For each input in the graph of y equal to 2x squared, the output will be twice as much as the output for y equal to x squared. For example, for x equal to 2, y equal to x squared will be have an output of 4. For x equal to 2, the output here will be 8. Now for each input, the output will be greater here. That means the parabola will go narrow. Can you understand that? Well, think about it. So if this is the graph of y equal to x squared, then the graph of y equal to 2x squared will be narrower. That is the red graph. Alright, so the graph of y equal to 2x squared is narrower than the graph of y equal to x squared. Now tell me, how does the graph of y equal to 1/2 x squared going to look like? If for each input y equal to 2x squared is greater than, in the case of y equal to x squared, for y equal to 1/2 x squared, you can see for each input the output will be less. That makes the graph go flatter or wider. There you are, the graph of y equal to 1/2 x squared. Think about it and try to mark some points on your own on a sheet of paper and study this. Alright, so the graph of y equal to ax squared is called a parabola. Y equal to ax squared is the equation of a parabola. Now tell me, what is the role of that a there? What does a do? A decides whether the parabola is narrower, broader, also its orientation. What happens if a is negative? If a is negative, the graph reflects on the x-axis. So y equal to ax squared, the graph is called a parabola where a is a constant and the shape and orientation of the parabola depends on the value of a. For larger positive values, the graph will go narrower. For smaller values, the graph will go broader. And for negative values of x, the graph will invert, will reflect on the x-axis, and so on. If a is positive, the parabola opens up. If a is negative, the parabola opens down. A large a value makes the parabola narrower, and a small a value makes it broader. Alright? Okay, now here I have an animation of the graph of y equal to ax squared. I would like to acknowledge the use of this open website for this. So I will be using many such open websites, and every time I acknowledge it with that website address. Now here, if you see, if I slide this, I can change the value of a 0 and less than and greater and so on. Now watch the behavior when I change the value of a. Increase the value of a, the parabola goes narrower. Alright, decrease the value of a, goes broader. And now a equal to 0. That means there's no graph. Now a is negative. Look at the way it behaves. So the orientation and the shape of the parabola is determined by the value of A. A very important information. Now we will see how the graph of a basic function shifted to the right or left gives you the graph of some relative function. Horizontal shift. Alright, let's now investigate how the graph of f of x equal to x plus 1 all squared differ from the graph of f of x, g of x equal to x squared. So you got two functions here, f of x equal to x plus 1 all squared and g of x equal to x squared. How does these two graphs differ? Very simple, you can draw it on your calculator. Alright, on the graph window type in y1 equal to x squared and type y2 equal to x plus 1 all squared, then graph them one after the other. How do you do that? Well, after typing them, deselect y2 so that first when you press graph, only y1 will be graphed. And then go and select y2, then y2 also will be graphed. That's what I want you to do. First graph y1 equal to x squared, then graph y2 equal to x plus 1 all squared. Now, keep watch here. It is x plus 1, the quantity is squared. Alright? Now, this is the graph of f of x equal to x squared. And this is the graph of f of x equal to x plus 1 all squared. What is the difference here? You can look at that and tell me what is the difference. The graph of x plus 1 all squared is obtained by simply shifting the graph of f of x equal to x squared one place to the left, 1 unit to the left. So f of x equal to x plus 1 all squared can be obtained by shifting the graph of g of x equal to x squared one position to the left. Alright, in that case, what will be the graph of f of x equal to x plus 5 all squared? Well, it will be the graph of f of x equal to x squared will shift 5 units to the left. It will be like this. Alright. So, the graph of g of x equal to x plus 1 all squared is obtained by shifting the graph of f of x equal to x squared 1 unit to the left. How about this? H of x equal to x minus 1 all squared. Now, go and graph this on the same window and look at how that looks. Well, there is the graph of h of x equal to x minus 1 all squared. What is the difference? When you have x plus 1, the shift is 1 unit to the left. When you have x minus 1, the shift is 1 unit to the right. That's right. So, how about this? The graph of g of x equal to x minus 3 all squared can be obtained by shifting the basic graph 3 units to the right. There you are. This is the graph of f of x equal to, or g of x equal to x minus 3 all squared. Well, you can now draw any graph of the form f of x equal to x plus a all squared. Can you? Well, look at the general form. In general, the graph of g of x equal to x minus h all squared. I want you to look at this. In the general form, the sign is negative, not positive. So this is the general form of the parabola. Gx equal to x minus h all squared is obtained by shifting the graph of f of x equal to x squared h units to the right. H units to the right. That means when this h is positive, the shift is to the right. You see, when h is positive, this sign is negative. But when h is negative, this sign will become positive. And that is when you get the shift to the left. Very often students confuse here. Knowing that this is the general form, when it is in this form, h is positive. When h has a negative value, that negative value will make the sign positive. So when h is positive, you get a shift to the right. H is negative, you get a shift to the left. And look at this, the graph of g of x equal to x plus h all squared is obtained by shifting the basic graph h units to the left. And you can see this x plus h can be obtained by using an h value that is negative. And this is the standard form that always used and not this. Alright? So keep note of that. This is our standard form. Alright. How about this? The graph of absolute value of x minus 2. Tell me, what is the value of h there? What is the value of h here? H is positive 2. So you will shift the graph of y equal to absolute value of x 2 units to the right. So if this is the graph of absolute value of x, and then shift it 2 units to the right, you have the graph of absolute value of x minus 2. I hope that concept is clear. How about this? Y equal to negative absolute value of x plus 2 is obtained by shifting the graph of y equal to absolute value of x 2 units to the left. Not this. Yeah. The y equal to, yeah, this is the graph of a y equal to negative absolute value of x plus 2. So if you remember how the graph of negative absolute value of x look, translate that 2 units to the left, because in this case the h value is negative. Now did you understand when I say the h value is negative? Here h value is positive. Here h value is negative. That negative makes that positive. So y equal to negative absolute value of x plus 2 is obtained by translating the graph of y equal to negative absolute value of x 2 units to the left. How about this? Y equal to x plus 3 all cube. Now remember, here we are dealing with the basic graph of y equal to x cubed. Now tell me, is the translation to the left or to the right? Well, the translation is to the right. So the translation is to the left. So the graph of y equal to x plus 3 all cube is obtained by shifting the graph of y equal to x cubed 3 units to the left. Let's draw that graph. This is the graph of y equal to x cubed. Now, shift it 3 units to the left, what will happen? Look at that. Now, what do you mean by shifting 3 units to the left? You can actually take any point on the graph and shift it 3 units to the left. This point is shifted 3 units to come here. This point is shifted 3 units to come here. That's what it means. You can actually take any point on the basic graph and shift it to get the related graph. How about this? The graph of y equal to x minus 3 all to the power of 3 can be obtained by shifting the graph of y equal to x cubed what way? Which way? 3 units to the right. Here the h value is positive. Well, don't get confused again. You must understand, in this case the h value is negative. In this case the h value is positive. Alright, so this is the graph of y equal to x minus 3 all to the power of 3. It is translated 3 places to the right. Let's practice some more. Y equal to square root of x plus 3. Alright, tell me what's the value of h there? H is negative 3. That means the shift is to the left. So the graph of y equal to square root x plus 3 is obtained by shifting the graph of y equal to square root 3 units to the left. This is y equal to square root x. Shifted 3 units to the left, you get the graph of y equal to square root x plus 3. How about this? The graph of y equal to square root x minus 1. Your h value is positive 1. So you shift the basic graph of y equal to square root x 1 unit to the right. There you have the graph of y equal to square root x minus 1. So once again, this is the green graph y equal to square root x. Red graph y equal to square root x plus 3, shifting 3 units to the left. And y equal to square root x minus 1, a shift of 1 unit to the right. In general, look at this. A graph of f of x minus h, this is the general form, f of x minus h is obtained by shifting the graph of f of x h units horizontally. And now, if this sign is negative, then h is positive. If this sign is positive, then h is negative. Now, for a positive h value, the shift is to the right. For a negative h value, the shift is to the left. I hope you don't confuse that. Alright, if h is positive, the shift is to the right. If h is positive, this will remain negative. The shift is to the right. If h is negative, this will become positive, and the shift will be then to the left. Okay, so far we were talking about horizontal shift. How about vertical shift? How does that happen? Okay, let's investigate. How about the graphs of f of x equal to x squared plus 2 related to the graph of f of x equal to x squared? Now remember, look at the difference between the earlier relation and now. Earlier we related the graph of f of x with the graph of f of x minus h. X was replaced by x minus h. But this time it is slightly different. This is f of x equal to x squared plus 2 related to f of x equal to x squared. Well, type in the two functions on your y equal to and graph them. This is y equal to x squared. And how is this going to be? If you notice, for every input you get the output is 2 more than the basic. That means the output will simply be raised 2 units for every input. That's what's going to happen. So this is the graph of f of x equal to x squared plus 2. It will be simply raised up by 2 units. Now, my graphing, sometimes it moves away a bit. This is supposed to be at y equal to 2. So every point on the graph is raised 2 points, 2 units. Why? Because for every input, the output is obtained by adding 2. The graph of f of x equal to x squared plus 2 can be obtained by shifting the graph of f of x squared 2 units up. That's a vertical shift. On the other hand, if it were x squared minus 2, the shift would have been down. Is that right? That's right. Alright, how about this? H of x equal to x squared minus 1. How will the graph of this look? Or how will you obtain this graph from the basic graph of g of x equal to x squared? Shift it 1 unit down. So the graph of h of x equal to x squared minus 1 is obtained by shifting the graph of g of x equal to x squared 1 unit down. Let's now do this. I'm sure you can do this on your own. The graph of y equal to square root x plus 2 is obtained by shifting the graph of y equal to square root x 2 units up. So this is the graph of y equal to square root x, and this is the graph of y equal to square root x plus 2. Alright, how about this? Graph of y equal to square root x minus 3. Now again, be careful. This is not square root x minus 3. This is square root x minus 3. Now the graph of this is obtained by shifting the graph of y equal to square root x 3 units down. There you have the graph of square root x minus 3. Always take care. Don't read it square root x minus 3. It is not. It is y equal to square root x minus 3. In general, look at this general form again. The graph of f of x plus k. In other words, with the graph, with the f of x, you add a constant k. Here k is 2 and here k is negative 3. So in general, the graph of f of x plus k is obtained by shifting the graph of f of x k units vertically. Now look at this. If k is positive, the shift is upward. If k is negative, the shift is downward. Alright, let's now combine the vertical and horizontal shifts. The horizontal shift, you know, depends on the value of h. If h is positive, shift to the right. If h is negative, shift to the left. Now when I move my hand, when I say right, it looks left to you because the picture is taking the opposite. Is that right? So when I say right, it looks left to you. So take that into consideration when you listen to me and watch me. Now we will now explore how vertical and horizontal shifts can be used to obtain the graphs of functions from the basic functions. Now, what is the general form? The general form is this: f of x minus h plus k. F of, remember this, f of x minus h, horizontal shift, plus k, vertical shift. Now, if this is the graph of f of x, this is the graph of a related function. You can see, tell me the values of h and k here. You have a 3 unit shift to the left. What is the value of h? H is negative 3. And a shift of 1 unit up, k equal to 1. So you got h equal to negative 3, k equal to 1, and that is, alright, so this will be f of x plus h. How does it become plus? Because h is negative. Remember, this is the standard form. When h is positive, the sign will remain negative. When h is negative, that sign will become positive. Now tell me, what is the form for this? What is the horizontal shift? Now look at the vertex here, this point. You can take actually any point. This is more convenient. It is being shifted 2 units to the right and 3 units down. So if you take this point on the parabola, it's being shifted 2 units to the right and 3 units down. That means your h is positive 2 and your k is negative 3. So it will be f of x minus h minus k. Your h is positive 2 and your k is negative 3. So I want to emphasize one more time, this is the general form. When h is positive, this sign will remain negative. When h is negative, that sign will become positive. Okay, if h is positive, the horizontal shift will be to the right. And if h is negative, the horizontal shift will be to the left. Alright, get that point very, very clear. If k is positive, the vertical shift will be up. If k is negative, the vertical shift will be down. This is a very important slide and you've got to keep the results with you. Alright, let's look at reflection about the y-axis. When does reflection about y-axis occurs? Now, look at these two functions. Y equal to square root negative x. Now, I want you to understand the difference between negative square root x and square root of negative x. Alright? Now, how does this relate to the graph of y equal to square root x? Let's plot these graphs on TI-83. Alright, put this on your calculator and enter like this. y1 equal to square root of x. y2 is square root of negative x. And graph it. Look at that graph of y equal to square root of x. And the graph of y equal to square root negative x. It is not negative square root x, but square root of negative x. Look at this. If you keep a mirror on the y-axis, the reflection of the graph of y equal to square root x will give you the graph of y equal to negative square root of x. So the graph of y equal to negative square root x, I'm sorry, I made a mistake. The graph of y equal to square root negative x is the reflection of the graph of y equal to square root x on the y-axis. The domain of y equal to square root negative x. Now, what is the domain of this? The domain only contains the negative numbers, negative infinity to 0. And the range is 0 to infinity. How about the graph of f of x equal to negative x all cube? Again, there is a distinction between f of x equal to negative x cube and f of x equal to negative x all cube. Is the reflection of g of x on the y-axis. Look at this. This is the graph of f of x equal to x cubed. And reflected on the y-axis, you get the graph of f of x equal to negative x cubed. Alright. In general, the graph of f of negative x is the reflection of the graph of f of x on the y-axis. Now, I want you to pay special attention to this. Tell me if you are following what I'm saying. What is the difference between negative f of x and f of negative x? Well, the graph of negative f of x is obtained by reflecting the graph of f of x on the x-axis, whereas the graph of f of negative x is obtained by reflecting the graph of f of x on the y-axis. I want you to understand the difference between these two. Negative f of x, f of negative x. Alright, let's practice with more examples. Use the graph of f of x equal to x squared and the form g of x equal to f of x minus h plus k to plot the graph of, look at this, g of x equal to x minus 1 all squared plus 2. Alright, what's the difference here? X minus 1, h equal to positive 1, a shift of 1 unit to the right, and a shift of 2 units vertically up. That means if you draw the graph of f of x equal to x squared and shift it 1 unit to the right, and 2 units to vertically up, you will get the graph of g of x equal to x minus 1 to the power of 2 plus 2. Alright, h equal to 1, k equal to 2 is shift 1 unit to the right and 2 units up. There is the graph. Now what I would suggest you do is choose a point for your shifting. Choose this point, shift 1 unit to the right and 2 units up. That point will now sit here, and now you can draw your graph. There you go. Okay, how about the next one? H of x is 2 times x plus 1 all squared minus 1. Now what does this 2 do? That 2 will make the graph narrower. Shift 1 unit to the left, h is negative 1, and 1 unit down. Alright, so you got h equal to negative 1. See, when that sign is positive, your h is negative. H is negative 1, k is negative 1. The graph is narrower. Horizontal shift 1 unit to the left, vertical shift 1 unit down. There is the graph of this 2 times x plus 1 squared minus 1. Again, take this, shift 1 unit to the left and 1 unit down. Alright, now the third one, g of x is 1/2 x minus 2 all squared minus 2. This 1/2 will make the graph broader. X minus 2 means h is positive 2 and k is negative 2. H is negative 2, h is positive 2, k is negative 2. The graph is broader, shifts 2 units to the right and 2 units down, and this is the graph of g of x equal to 1/2 x minus 2 all squared minus 2. You need to practice it by taking, you can actually manipulate these and make more examples and start plotting on your own. Now try these on your calculator. Alright, next one. Use the graph of f of x equal to square root x to plot the graphs of these functions. Alright, let's look at each of those. Now this is the graph of the basic function. F of x equal to square root of x. And now how do we shift it to get g of x equal to square root x minus 2 plus 2? Alright, in this case, your h is positive and your k is positive. H is positive 2, k is positive 2. So this graph will shift 2 units to the right and 2 units up. It will be like this. You can see I translated this point 2 units to the right and 2 units up, and that is the graph of g of x is square root x plus 2 plus 2. How about the next one? G of x is negative square root of x plus 2. What does this negative do? Again, look at the difference between negative f of x and f of negative x. Don't confuse that. This negative will reflect the graph on the x-axis. That's right. So h equal to negative 2, k equal to 0, and the reflection on the x-axis. So the basic graph will reflect on the x-axis and then shift 2 units to the left, and there is no other translation. So reflection on the x-axis and shifts 2 units to the left. So first of all, you reflect the basic graph on the x-axis. It will be like this, and then shift it 2 units to the left. There is the graph. Alright. How about the next one? Oh, this is very good. G of x is square root of negative x plus 2. Now, this you need to actually write it in the standard form, by factoring out a negative in here. So we factor out a negative sign inside the square root, and look at the way I write it. This is the same as g of x is square root of negative x minus 2. You see, we can only handle this form, not this form. So negative x plus 2 needs to be written as negative x minus 2. In other words, what happens is, what is the role of this negative? That is f of negative x, reflection on the y-axis. So here we have a reflection on the y-axis and a shift of 2 units to the right, h equal to positive 2. So h equal to positive 2, k equal to 0, and reflection on the y-axis. Can you reflect this on the y-axis? When you reflect it on the y-axis, it will look like this. Follow my marker. That is reflection on the y-axis. Then shift it 2 units to the right. So this reflection, shift 2 units to the right, will go that way. There you are. So there is the graph of g of x is square root negative x minus 2. So again, you've got to watch this couple of times and practice it on your own. Important skills. Another one. F of x equal to absolute value of x. We're going to use that to obtain the graphs of these three functions. Alright, let's do that. This is the graph of absolute value of x. Now, let's take the first one. G of x is absolute value of x plus 2 minus 1. Here, your h is, tell me, h is positive or negative? H is negative 2, k is negative 1. Now, it shifts 2 units to the left and 1 unit down. So, this point goes 2 units to the left and 1 unit down, and this is the graph of g of x is absolute value of x plus 2 minus 1. Alright, how about the next one? G of x is negative absolute value of x minus 1. This is the form f of x equal to is negative f of x. In other words, that negative makes the reflection about the x-axis. So don't confuse again there. So first of all, a reflection about the x-axis and a translation of 1 unit to the right. So you reflect this about the x-axis, you will get there, and translate 1 unit to the right. You got h equal to 1, k equal to 0, reflection on the x-axis, and shifts 1 unit to the right. So watch my marker again. Reflection on the x-axis will give me this. And shifts 1 unit to the right will give me that. There you go. Okay, the next one. G of x equal to 2 times absolute value of x minus 2 plus 1. First of all, what does this 2 do? 2 will make this graph narrower. H equal to 2, k equal to 1. So you got h equal to 2, k equal to 1. The graph is narrower. It shifts 2 units to the right and 1 unit up. So it'll be narrow, shifts 2 units to the right and 1 unit up. It will be like this. Okay, I hope you are grasping this concept, very important concept. Another one, graph of f of x equal to x cubed. That's the basic graph, f of x equal to x cubed. We use that to graph these three given functions. First we have g of x equal to x cubed plus 2. Tell me, what is the h value here for the horizontal shift? There is no h there. X minus h is 0. K is 2. So h equal to 0, k equal to 2 means vertical shift 2 units up. You simply move this 2 units up. That is the graph of x cubed plus 2. Next one, g of x is x plus 2 all to the power of 2, all to the power of 3. Now, what's the value of h there? H is negative 2. In other words, here this will shift 2 places to the left. H equal to negative 2, k equal to 0. You have shift 2 units to the left, and that's it. So you can see this point is now sitting there. The graph shifted 2 units to the left. Alright, the last one, g of x is x minus 2 all to the power of 3 minus 1. Well, here there is a horizontal shift and a vertical shift. What is the horizontal shift? H equal to 2, positive 2, and k equal to negative 1. Shift 2 units to the right and 1 unit down. So the basic graph will shift 2 units to the right and 1 unit down. There is your graph of x minus 2 all cube minus 1. Alright, let's go and find more of these. You can actually try all these on the calculator. That's what I would do, because you've got to be inquisitive in finding more about these. Okay, use the given graph of f of x to plot the graph of g of x equal to f of x minus 2 plus 2. Alright, let's look at the given graph. Now here is the given graph of f of x. How would you draw the graph of f of x minus 2 plus 2? Well, in order to do this, you've got to identify your h and k. What is your h there? H is positive 2 and k is positive 2. That means this will now shift 2 units to the right and 2 units up. It will be, well, it will shift, yes, h equal to 2, k equal to 2. That means each point, this point will shift 2 units to the right and 2 units up. The graph will be like this. Well, you can see obviously I haven't drawn that correctly, so let me go and draw it well. You can see, take a point here, shift it 2 units to the right here and 2 units up. The graph will look like this. That's right. So the shift is 2 units to the right and 2 units up. Alright, I'm going to erase that now. Okay, how about this? H of x equal to negative f of x minus 2. In other words, what does negative f of x do? Negative f of x is reflection on the x-axis. Alright, let's talk about it again. What does f of negative x do? Again, distinguish the two. Negative f of x, f of negative x. Negative f of x is reflection on the x-axis. F of negative x is reflection on the y-axis. So here we have reflection on the x-axis. And tell me, what does this 2 stands for? Is it h or k? Now remember, h is what comes with x. F of x plus h. This is your k. So h is 0 here. What is done is, you got a reflection on the x-axis and a translation of 2 units down. So h equal to 0, k equal to negative 2, reflection on the x-axis, and can you therefore do that? It reflects on the x-axis and 2 units down. It reflects on the x-axis. When it reflects on the x-axis, it'll come like this, and 2 units down. This is the graph of negative f of x minus 2. All right. How about the third one? All right, this is very important. G of x is f of negative x plus 1 minus 1. What does f of negative x plus 1 do? What is that negative sign signify? That is a reflection on the y-axis. Now look at this. If you reflect the graph of f of x on the y-axis, will there be any change? No. Actually, if you reflect this graph on the y-axis, did I say x-axis? Now, if you reflect this graph on the y-axis, there will be no change. So symmetric, this is actually symmetric about the y-axis. So, watch again here. What is the h value here? H value is negative 1 and k value is negative 1. So what that means is reflect on the y-axis, then shift 1 unit to the left and 1 unit down. So reflection on the y-axis, and since this graph is symmetric about the y-axis, reflecting on the y-axis will not cause any change. So what all we need to do is translate 1 unit to the left and 1 unit down, and that is the graph of f of negative x plus 1 minus 1. Now here again I have a website that I have acknowledged earlier, and it asks you, if you are given certain graphs of the functions and you are given the equations, and what you need to do is drag the correct graph and place it in its correct place. Alright, let's talk about it. X squared minus 2, I hope you can see that. X squared minus 2, which of these graphs is the graph of x squared minus 2? The graph of x squared is a parabola. X squared minus 2 is this, so that will fit there. Alright, 2 minus x. Look at these graphs and tell me which of these corresponds to 2 minus x. Now you've got to read it like this. The graph of negative x. Now you see the graph of y equal to x will be a straight line like this. The y equal to negative x will be a straight line like this. And y equal to negative x plus 2, you've got to read it like this, negative x plus 2. So the graph of negative x is shifted 2 units up. Which one is that? Is it this or that? Well, this is actually the graph of positive x shifted. This is the graph of negative x shifted 2 units up. That will fit there. Alright, how about this? I'm going to ask you to leave it because we haven't actually talked about this kind of graph. And also that one. 2 of them we are going to leave. How about x minus 2 all squared? X minus 2 all squared. A shift of 2 units to the right of the graph of x squared. And finally, x plus 2. So let's move these. We said this belongs there, and this belongs here, is that right? And this belongs there, and this will belong here, is that right? X plus 2. And let's say, we can now do by elimination and take the other 2. Look at this. This is a parabola, it's a second degree, and therefore this is the equation for that. This is a cubic function, and therefore this is where it will fit. And let's move that over there, and this over here, and it should work. Okay, we will now look at even and odd functions. An even function has a y symmetry, and well, what is y symmetry? Let's look at the graph of f of x equal to x squared. The y-axis divides this graph into 2 equal parts, one on the left and one on the right, and they are exactly alike. Is that right? The point 24 is on the right, and the point negative 24 is on the left. The graph of f of x is said to be symmetric about the y-axis. Now, if f of x equal to x squared, what is f of negative x? If you replace x by negative x, what will happen? Well, since it is squared, replacing x by negative x will not make any difference. To obtain f of negative x, we replace x by negative x in the function, and what you get? F of negative x is negative x all squared equal to x squared. That means replacing x by negative x in the function will give you back the function. The function doesn't change. And that is the requirement for a function to be symmetric about the y-axis, or for a function to be an even function. For this function, which is symmetric about the y-axis, look at the condition. What is the condition for a function to be symmetric about the y-axis? F of negative x must be equal to f of x. Such a function where f of negative x equal to f of x is called an even function. And the graph of an even function will be symmetric about the y-axis. That's right, very important. Now, what's an odd function or origin symmetry? Let's look at the graph of f of x equal to x cubed. Now, look at the graph of f of x equal to x cubed. Now, this one, if you reflect about the x-axis and then about the y-axis, you actually get back the same graph. Well, you can see the point 28 is on the graph, and the point negative 2, negative 8 is also on the graph. That is 28 and negative 2, negative 8 are 2 points at equal distance from the origin. That distance equal to this distance. There you are. Now, points corresponding to inputs and outputs of opposite signs are at the same distance from the origin. Such a function is said to have an origin symmetry. Now tell me, if f of x equal to x cubed, what is f of negative x? What happens if you replace your x by negative x in this function? Well, let's do that. If f of x equal to x cubed, let's find what is f of negative x. Replace x by negative x. Negative x all cube is the same as negative x times negative x times negative x, and that is negative x cubed. So you notice that f of negative x is the same as negative f of x. Now you notice I told you negative f of x gives you the x-axis reflection, and f of negative x gives you reflection about the y-axis. Now what is happening here is f of negative x is the same as negative f of x. Reflection on the y-axis is the same as the reflection on the x-axis. Now for this function, which is symmetric about the origin, f of negative x is the same as negative f of x. And that is the condition for a function to be an odd function or to have origin symmetry. So such a function where f of negative x equal to negative f of x is called an odd function, and an odd function has an origin symmetry. An even function has a y-axis symmetry. Alright, check if the function f of x equal to x cubed minus x is even, odd, or neither. Now, how do you do it? But all you need to do is find the value of, or find the form of f of negative x. Now remember, if f of x equal to f of negative x, then that indicates an even function, y-axis symmetry. If f of negative x equal to negative f of x, that indicates an odd function. Alright, let's find f of negative x. F of negative x is negative x all cube minus negative x, and that will be negative x cube plus 3. Alright, tell me, what is the conclusion? You can actually factor out a negative sign from here. Look at the way negative x cube plus x is negative x cube minus x. That means when you replace x in f of x, you produce f of negative x, and that f of negative x is negative of f of x. This is f of x. So what we have is f of negative x is negative of f of x, and that is the condition for a function being an odd function. So this function is an odd function. It has an origin symmetry. Now look at the graph of that. Okay, how about this? Check if the function f of x equal to x to the power of 4 plus 3x squared minus 5 is even, odd, or neither. As usual, we find f of negative x. In other words, in the function, replace each of these x by negative x. That gives you negative x raised to the power of 4 plus 3 negative x raised to the power of 2 minus 5. Now, because the powers both are even, a negative quantity raised to an even function will become positive. So that will be x to the power of 4 plus 3x squared minus 5, which is the same as our function f of x. So what we see here, f of negative x is the same as f of x, and therefore the function has y-axis symmetry. It is an even function. Alright, and look at that graph. The graph of that function has a y-axis symmetry. Another one. Check if f of x equal to x squared minus x plus 1 is even, odd, or neither. Well, let's replace our x by negative x. What is f of negative x? It is negative x all squared minus negative x plus 1, and that will be x squared minus become positive plus x plus 1. Can this be written as negative f of x or in any of the f of x form? No. This is not equal to f of x or negative f of x. Therefore, the function is neither odd nor even. Alright, so these kind of skills are again important for you. And you can see the graph of that function. It has no symmetry. It has no y-axis symmetry. It has no origin symmetry. Therefore, it is not even. It is not odd. And that brings us to the end of this lesson. As I normally say, after watching a lesson, you always go back and do that homework. Very important. And get back to me for additional help if you need.